Okay, so one section for today, we're going to talk about unit conversions. This is a little extension of last time we talked about converting in the metric system. And if you remember, the nice thing about converting in the metric system is since everything is base 10, like our number system, converting between one unit of measure and another was just a matter of moving the decimal place. So converting between kilometers and centimeters is just a matter of moving the decimal place in the appropriate direction. But what happens is we use the US system for length. We have feet and yards and miles. For mass, we have pounds and tons. For volume, we have cups and pints and quarts. And the thing is, there is no uniform conversion between those, and that presents a little bit of a problem. So today's information is about doing unit conversions. This is super useful, not just for converting in the US system, but converting between the US system and the metric system. This is a great skill to have. You'll probably use this, or maybe you've already used this in your science class. So here we go. Example one, this is mine. Hopefully you'll catch on to this, but we're going to do a bunch of exercises and we'll see how you do. So what we're going to do is we're going to convert 4 gallons to quarts. So here's how you do unit conversion. Okay, what we're going to do is we're going to start out, we're going to write where we're starting, 4 gallons. I'm going to abbreviate gal for gallons, okay, just because I'm feeling lazy with my writing. Now what I'm going to do is I'm going to find the conversion between gallons and quarts over to the right. Now I'll give you the conversions on the test. I do not expect you to memorize all the US conversions or the metric US conversions. I mean, there's some of them you might already know. You probably know a foot is 12 inches, things like that. All right, so I come over here to my chart and I see that a gallon is 4 quarts. It's right here. So I'm going to use that to create what's called a unit ratio. Okay, and my unit ratio is how I'm going to convert. So I'm going to multiply. I'm going to use an X for multiplying, and I'm going to, bless you, and I'm going to create a unit ratio right here. And so I know the conversion is 4 quarts equals 1 gallon. Now here's what I'm going to do with my ratio. I'm going to take the 4 quarts, I'm going to put it up top, and the 1 gallon I'm going to put in the bottom. And here's why I'm doing this. I started with gallons. I want to cancel the gallons. I don't want them to be there. That's why I put the gallons in the denominator here. Because now I have gallons in the numerator, I have gallons in the denominator. These will cancel. And now I'm left with the units that I want, which are quarts. So I don't know if any of you, you're in high school and your teacher's trying to tell you when you're converting from a bigger unit to a lower, you multiply, and a lower to a bigger, you divide. That is too confusing for me. My brain can't wrap around it. I always forget it. When you use your unit conversions and your unit ratio, you don't have to remember any gimmicks like that. Okay, this will always tell you. And now what I know is I'm going to do 4 times 4, and that's going to be 16 quarts. So the big thing that you have to get used to, and the big thing we are going to practice in the next examples, is structuring this unit fraction, this unit conversion, my ratio here, so that I cancel out the units that I don't want, and I'm left with the units that I do want. So with that said, exercise 1 for you. I'm going to give you a minute or two to do this. Convert 936 feet to yards. Even if you know what the conversion is, set up the ratio to practice it so that when you are using unfamiliar conversions, you'll know what to do. Okay, that's what I'm asking you to do here. All right, here goes. You give this one a try. Ask any questions you need to, because once it clicks for you, it's the same thing every time. So in this exercise, we are starting with 936 feet. I am now going to multiply by my conversion ratio that I have. And so I look at the table. The conversion ratio between feet and yards is right here. It says that 1 yard is equal to 3 feet. So when I am deciding which one's going to go in the numerator and which one's going to go in the denominator, what am I going to put where? Where's the 1 yard going to go? Where's the 3 feet going to go? Perfect. Thank you. Well said with confidence. The 3 feet's going to go at the bottom. And if you were struggling on that, it goes in the denominator so that my feet can cancel. So I have 1 yard is 3 feet. I got that from the table. That is the conversion, which I make into a ratio. Now my feet are in the bottom, so feet cancel with feet. And now that tells me to do what? What operation do I do between the 936 and the 3? I'm going to divide. Yeah, the 936 is in the numerator. The 3 is in the denominator. That tells me to divide. So when I divide 936 by 3, I get 312 yards. Does that make some semblance of sense? We doing okay? All right, well then go ahead and do the next one. Exercise 2. 620 hours, 2 days. Oh, you know what? I should help you with this one. No, I shouldn't. You got this. All right, so once again, on this one, we start out with the 620 hours. Okay, and I'm asked to convert this into days. So I'm going to multiply. Now, again, this is a conversion you knew, but even though you're familiar, I just want you to set up the conversion ratio, because in a moment, we're going to do one that you're probably not familiar with the direct conversion to. And so we know, you knew this, but I'm going to highlight it on the chart, that 1 day is 24 hours. So on my conversion ratio, where am I going to put what? Where am I going to put the 1 day? Where am I going to put the 24 hours? 1 day is in the top, and then the 24 hours is in the bottom. And again, we put the hours in the bottom because I started with hours in the top. I want to get rid of them. So now they'll cancel. I have 1 in the numerator and 1 in the denominator. That's why they cancel. And so also what this tells me is I am going to take the 620 and I'm going to divide it by the 24. So when I do that, 620 divided by 24 gives me 25.8 days. All right, next one, exercise 3 is a conversion between a metric unit and a US or an English system unit. So you're going to convert 900 centimeters to inches. All right, here we go. 900 centimeters. So this is a conversion that's probably unfamiliar to most everybody, but here it is right here. 1 inch is 2.54 centimeters. So I'm going to use that information to create a conversion ratio. And so when I do that, 1 inch is 2.54 centimeters. Where am I going to put the 1 inch? Numerator or denominator? Numerator. 1 inch is in the numerator, and the 2.54 centimeters goes in the denominator. Okay, so centimeters cancel. Now you just go to your calculator. This tells you, without having to guess, that you're going to take the 900. You're going to divide by 2.54. And I'm going to just round to the 10th place. I get 354.3 inches. Anybody get something different they have to talk about? Is anyone confused about why the inches go in the numerator and the centimeters go in the denominator on this particular problem? All right, well then we're going to do one more, and then we're going to take this to the next level. So go ahead and do exercise 4. Convert 150 pounds to kilograms. And that conversion is toward the bottom, just to direct your attention. Well, what'd you get? How many kilograms? Okay, great. Let's see how you got that. That is a fantastic result, 67.5. So we start off with 150 pounds, and then we just look, and we look down here at the bottom. It says 1 pound is 0.45 kilograms. Again, probably an unfamiliar conversion. And so I think if I asked you, you would tell me that we're going to put the 1 pound in the denominator because I want my pounds to cancel. This pound is in the numerator, this one's in the denominator, and then we've got 0.45 kilograms. All right, and so now this tells me these numbers, after I cancel my pounds, I'm going to multiply these numbers. I'm just going to go straight across the top. So I take that 150 times the 0.45, and you've already told me the answer, it's 67.5 kilograms. Great job. I'm assuming, since we got all the time in the world today, that you would let me know if you're having an issue. So example 2 is mine. Sometimes what happens, and where this procedure really takes on its full significance, is when you don't know the direct conversion between something. So we're going to convert 10 miles to yards. Now there is a direct conversion on here, although it's not in our chart. So I'm just going to pretend that there's not a direct conversion. Okay, because sometimes we don't know. So what I'm going to do is 10 miles to yards. So here we go. I'm going to start with 10 miles. Well, I'm going to go look at my chart, and I'm going to see, can I convert from miles to something? So I'm sliding here, and according to my table, what do I know the relationship with? Miles and what? Okay, on my table, I know miles and feet. So 1 mile is 5,280 feet. So let's go here. 1 mile, I'm going to put the mile in the bottom, is 5,280 feet. I have put the mile in the denominator, so it cancels with the mile that I started with. So now my units are feet, but that's not what I wanted. I wanted to convert this to yards. So I'm going to do it again. Now I'm going to convert feet to yards, which we did in a previous problem. You can look up above at exercise 1. 1 yard is 3 feet. So 1 yard is 3 feet. And you can keep doing this on and on until you get the unit that you need. But we are there. We've converted miles into feet and then feet in the yards. And now I'm ready for my answer. So I go to my calculator and I start off with 10 times 5,280, which is going to be 52,800. Then I'm going to divide that by 3. And I get 17,600 yards. Now there is a direct conversion, and if you happen to know that, that's fine. Okay, so just on this particular one, I was assuming we didn't. All right, here's what I would like you to do. Again, well, I would like you to pretend, okay, we're going to live in the land of make-believe, okay, pretend, just because I want you to practice doing this with 2 steps. Let's pretend that we don't know that 1 foot is 30.5 centimeters. It's a bad conversion anyway. They rounded too soon. So here's what I would like you to do on this, just to practice. I want you to convert feet to inches and then inches to centimeters. Do this as a 2-step process, please. All right, so on this one, we're going to start with our 18 feet. I asked you to just pretend that there's not a direct conversion so that we're practicing the process. So we're going to convert the feet to inches. So in 1 foot, there is 12 inches. I intentionally put the feet in the denominator, so I've canceled. So I've done the first step. I've converted feet into inches, and that's what I have now. And now from there, I'm going to use the conversion we used in problem number 3. And we're going to convert the inches to centimeters. So 1 inch is 2.54 centimeters. And here's what we get. When I go to the calculator, I do 18 times 12. Then I'm going to multiply by 2.54. And I end up with 548.64 centimeters. My inches cancel, and there we go. The next one, there is not a direct conversion given, so you'll have to go through the process. Convert 13 days to seconds. How many seconds do you have to endure in 13 days? All right, so we're starting off with 13 days here. And I asked you to convert that to seconds. So you know this, but it's also on the table in case you didn't. that in one day we have 24 hours. Okay, so that's what I know so far. I can take days down to hours. Okay. So given different conversions, you could do this a different way. This is not the only way to do this particular problem. I'm just doing it with the conversions that I've been given. So now that I have hours, I need to take it to seconds. But again, I don't know off the top of my head how many seconds are in an hour. If you do, because you've done that before, then you can go with it. But what I'm going to do now is I'm going to take hours to minutes. So in a 1 hour, there is 60 minutes. So now I've taken days to hours. Now I've taken the hours, I've converted that to minutes. But I asked you for seconds. Now, if you knew there was 3,600 seconds in an hour, it doesn't take long to catch on to that. If you've seen it before, then you could have done this in one step. But I'm not assuming you did. I'm assuming you're using the table. And so now I got to take the minutes to seconds. And so I know that 1 minute has 60 seconds. And so I took the days, I converted them to hours, then I took the hours and converted them to minutes. Finally, I took the minutes and I'm left with the only units I have here are seconds. And so when I go to the calculator, I don't know where I'm going to write the answer because I did not do a good job of thinking ahead on my space here. And so 13 times 24 times 60 times 60 again gives me a lot of seconds, 1,123,200. So let me just write here, I'm going to write it right below here, 1,123,200 seconds is the answer to that problem. All right, we're almost done with this particular section. One more thing that I'm going to present to you here. Sometimes the unit that you're converting is not just a static unit like days or feet or miles. Sometimes you're given something called a rate. When you have the ratio of 2 units, that's called a rate. In case you've not heard that before, I'm just going to define that over here. A rate is a ratio of 2 units. Right, we're most familiar of that when we're in the car and we're driving at miles per hour. You can also use rates like when you're measuring how much water you're using. You have gallons per second or something like that. Rates are all over the place. So this particular problem, example 3, what we're going to do is we're going to convert 50 miles per hour to kilometers per minute. Okay, so if I'm driving down the road at 50 miles per hour, maybe I wonder, hey, how many kilometers per minute am I going? Just because that's the kind of thing we often think about. So here we go. I'm going to start over here with 50. Now I'm going to be intentional how I set this up. It's miles per hour. So miles is in the numerator and then hour is in the denominator. You got a question? You with me? We doing all right?
On the test, do we have to write like I did another fraction?
I would recommend it because what this is going to affect, like when I'm doing my conversion, when I put my unit ratio down, it's going to determine where I put my, like for instance, hours and minutes, where I put that in my unit ratio. So having good notation would be very helpful. Okay. If you can do the problem without, if you can write like the slash and hour, that's fine. You can do it that way. All right, so here goes. I'm going to deal with the miles first. That's just an arbitrary choice. You could deal with the hours first if you wanted to. Okay, so I'm going to deal with the miles first. I'm going to convert miles into kilometers because notice that's what's in the numerator. Miles needs to get changed into kilometers. So according to my table, do I have a conversion between miles and kilometers? Yes, I do. It's right here. 1 mile is 1.6 kilometers. Okay, great. So I'm going to use that. And so 1 mile, I'm putting that in the denominator. 1 mile is 1.6 kilometers. The reason I put the 1 mile in the denominator is the same reason for all the other problems. It's now going to cancel with the other mile. Times. So now what I have, if I finish the problem, okay, if I didn't go any further than this, what would the units of my answer be if I did not go any further? Kilometers per hour. Yeah, okay, I have kilometers on the top. I still have hours in the bottom. But that's not what I asked for. I asked for kilometers per minute. So now what I've got to do is I've got to change the hours into minutes. Okay, so I know in 1 hour, there's 60 minutes. We used that conversion earlier. So this time, according to the way the problem's set up, where am I going to put the 1 hour? Why am I putting it on the top? You're 100% right. Yeah, because the hour that already exists is in the bottom. So I'm going to put the 1 hour in the top is 60 minutes. So that's kind of the value of using unit ratios, conversion ratios, is you always know if you've put the units in the right place because you're canceling out the units. You always know if you're multiplying and dividing. So I've canceled my hours right there. I'm left with the units kilometers per minute, which is exactly what I asked for. So now I'm going to see by taking the 50, I'm first going to multiply it by 1.6 because they're both in the numerator. And then I'm going to take that and I'm going to divide by the 60 because that's in the denominator. And I'm going to just round that to the 10th place. That is 1.3 kilometers per minute. All right, the last problem for this sheet is exercise 7. Convert 5 liters per hour, that's what you're starting with, to cups per minute. All right, so depending on how you approach the problem, you're going to use the same 2 conversion ratios I do. You just might have done them in a different order. Doesn't matter. I'm going to tackle the liters first, but maybe you tackled the hours first. It does not matter. We will use the same 2 ratios. We'll end up with the same answer. So first thing I'm going to do is I'm going to deal with the numerator. I'm going to convert liters into cups. Okay, that's my goal. Liters into cups. So according to my table, 1 cup, I see right here, 1 cup is equal to 0.24 liters. Okay, so liters into cups, so 1 cup is equal to 0.24 liters. I put the liter in the bottom because, got to put an E in there, I put the liter in the bottom to cancel the liters in the top. So now if I stopped, I have cups per hour, but that's not what I want. I want cups per minute. So I need to convert the hours to minutes, just like we did the previous one. 1 hour is equal to 60 minutes. And we cancel the hours. And so now I'm left with cups per minute. Those are the only units left over. And now I go with my calculator, and my calculator tells me that 5 divided by 0.24, because this 0.24 is in the bottom. So 5 divided by 0.24. And then I'm going to divide again by 60. And I get 0.35 cups per minute. And there we go.